Today we are going to talk about graphing sine and cosine functions. So up to now we've been using the unit circle and special right triangles to identify values of sine and cosine, but those can be thought of as coordinates that we can plot on an XY graph. So you were supposed to do the exploration, and you should have found that a sine graph looked like this, and a cosine graph looked like this. All right, and that's what we're going to talk about today. We're going to go over some vocabulary that we use here to describe how to make the graph. Okay, so if you look at your guided notes, I put on there a graph of a sine function and a cosine function as well. So what I want you to see from this picture versus this picture here is that this is a graph that goes on and on forever in this oscillating pattern. So it's called a sinusoidal graph. It goes up and down between a certain width, right? But it continues on and on forever. So when the question on your exploration asked you what was the end behavior here, it's not ever stopping and going to just one point, okay? Its end behavior is that it's going to keep oscillating over a period of 2 pi up and down between 1 and -1, okay? So that's what it does. Also notice that when you're looking at these graphs, that your sine graph starts at 0, goes up, goes down, goes back up again. And over the course of 2 pi, it completes one full graph. When I get to here, I start going back up again, and I've already done that. So the unique part of this graph starts at 0, goes up to 1, comes down through pi, comes down to -1, goes back. That would be one cycle. You should recognize the difference between a sine graph and a cosine graph, right? So a sine graph starts at 0 and goes up. A cosine graph starts at 1, goes down to -1, and then back up. Now again, even when I get back up to where I started, I'm repeating the next cycle. So this would be one complete cycle of a sine graph. All right, if you noticed these two graphs, if I could physically pick one up and shift it around like a translation, I could get them to be on top of each other. All right, so what are some characteristics of this graph? If you look at your guided notes, the domain is all real numbers, right? I can plug in any number along the x-axis and I'm going to get a point on the graph. The range is only between 1 and -1. So for the parent function, the range would be all y's between -1 and 1, including -1 and 1. So the maximum value of this function is 1, and its minimum local min would be -1. The amplitude of a graph is the difference between this high number and low number, okay? So the amplitude of this graph right here is it's 1/2 the distance, I'm sorry, from the top to the bottom. So the distance between the top to the bottom for each one of these is 2, right? To go from -1 up to 1, the distance is 2. Half of that is 1. So we say its amplitude is 1. All right. Its period is the length on the x-axis it takes to complete a cycle, and a cycle is one complete loop of the graph. So we're going to talk about some of these terms a little bit more. All right, so let's look at all right. So we saw that the parent function, when a is 1 and b is 1, was a graph that had period of 2 pi because it completed its cycle in 2 pi. It started at 0 and it went between 1 and -1. So I came up here, I came down here, and then I went to there. Okay? That is the general pattern of how you want to draw a sine graph. So you're going to see what the period is and then divided it into 4 equal segments. So if I take the period being 2 pi and let's fix this, divide it in half, I get pi. I divide that in half again, I get pi over 2 and 3 pi over 2. So when we're drawing a graph, that's what we want to do. First thing we're going to do is we're going to divide the period into 4 equal sections. And then we're going to label how the maximum and minimum value. So in this case, our maximum and minimum were 1 and -1. Our period was 2 pi, because that is what it is for a parent function. Now, if I change these numbers at all, so let's say, for example, I do the function g of x equals the sine of 2x. All right, so now I've added a b, okay? My a is still 1. The a, absolute value of a, stands for the amplitude. A for amplitude. And what that tells, and the formula for amplitude is, it tells me how high in between here that I am going, okay? So to find the amplitude, we do 1/2, absolute value of 1/2, the max value minus the min value. So in this case, 1 minus a -1 is 2, half of 2 is 1. And this, because my a is 1, my amplitude is still 1. So for this graph here, we're still going to be oscillating between 1 and -1. But now this 2 stands for my b, and my b is standing for my period, okay? It helps me find the period. All right, the volume for the period, or how over what period of the x-axis we're going to make our first cycle, is always going to be 2 pi over the absolute value of b. All right, so in this case, when we're doing the sine of 2x, we are going to do 2 pi over the absolute value of 2. And that would be my period. So that comes out to be pi. So we are, if the way of thinking of it, shrinking our graph by a factor of 1/2, right? We're at period before was at 2 pi, and now we're squishing it in, and we're going to do the whole loop in just a pi amount of length. All right, so I'm going to divide my axis here. So here's pi. So now my halfway point is going to be pi over 2, and then these points in between are going to be pi over 4 and 3 pi over 4. A sine graph starts at 0. At the first fourth, it goes up. At the second, it crosses the x-axis. Then at the third one, it comes down to -1. And at the fourth one, it comes back up to pi. All right, so that's how I would graph sine of 2x. So it's the same shape, it's just doing it over a period of pi instead of 2 pi. Now it keeps going, so if I had to do it up to 2 pi, which sometimes they ask you to do, okay, this would be, yeah, 3 pi over 2. It would keep going. It would go up here again, oops, to 1, down here again, to -1, and back up again. So in the period of 2 pi, I can actually fit 2 cycles in here. Okay? And then that same thing holds true for cosine as well. So if you have this is in those guided notes. We're going to talk about translations up and down and right and left tomorrow. We're just going to stay today talking about what happens if I change the amplitude and what happens if I change the period. So let's do an example where we change both. Okay. So here we try this example, g of x equals 1/3 cosine of 2x. So the a in this case is 1/3 and the b in this case is 2. All right, so this tells me, a tells me that the absolute value of a is going to be my amplitude. So that means the distance between, half the distance between the higher number and the lower number is 1/3. Since we're not shifting this up or down at all, that tells me that my graph is going to come between 1/3 and -1/3. All right, b is 2, so we're gonna have the same period as we had the last time. Period is 2 pi over the absolute value of 2, which equals pi. So again, I'm going to break the pi into 4 equal sections. So that's pi over 4, pi over 2, 3 pi over 4, pi. Okay, that would be 4 equal sections. All right, cosine graph, if we remember how a cosine graph starts, a cosine graph starts at the max. It comes down through pi over 4. I'm going to change my color here. Come down through pi over 4, gets to its min here, comes back up through here and goes back up to 1/3. And see how it does not like a parabola. It's kind of like this because it's getting ready to go back down again. Okay. I could have made this a little bit neater. This marker's running. I'm going to have to get another one. Okay. All right, so that would be 1 period. And if I wanted to continue it, I could continue it in the positive direction, or I could continue it in the negative direction. All right, let's try another example that maybe has a different period. All right, let's try this one. We'll leave it g of x equals 4 sine 2 pi over x. All right, so the absolute value of a is 4. So we know our amplitude is 4 and our period is going to be 2 pi over the absolute value of 2 pi. Right, because b here is 2 pi. So my period here is just 1. Oh no, what does that mean? I can't divide my 4 sections here into pi's. That's okay. Remember, pi just stands for 3.114. So if I just have my, if I have just 1, my period just being 1, I'm just going to divide it into 1/2, 1/4, and 3/4. Okay, my amplitude is 4. So this is going to be a pretty tall graph. So this is sine. So sine starts at 0. It's going to go up to 1/2, back to 0, up to 4, I mean, up to 4, down to -4, and back up to 0. So it's going to go up and down and back up again. All right, I'm going to do one more example, and I'm going to then you'll be done. How about all right, so here the absolute value of A is 1/2, and my period is 2 pi over the absolute value of 3 pi. Pi's cancel out, so I just get 2/3. All right, I'm going to increase my scale a little bit here, because if I just start over here at 2/3, we are not going to be able to see the 4 sections very well. All right, so I'm just going to make my 2/3 a little bit bigger. All right, 2/3 times 1/2 is 1/3. 1/3 times 1/2 of that is 1/6. All right, in between here, this is 2/6 and 4/6. This is 2/6. This is 4/6. So in between here would be 3/6 or 1/2. No, 4/6. Is that right? Yeah, I did that wrong on my paper, but yes. All right, this is a cosine graph. It's going to start at 1/2, go down to -1/2. It starts up high, goes down through 0, goes down to -1/2, comes back up to 0, and ends at 1/2. So I want to go down, up, like that. Okay. All right, that's as far as we're going to do in this lesson today, so keep your guided notes. We'll use them again tomorrow.